Hello, everyone. This video is going to be devoted to problems from 11.6. So problems on absolute convergence, conditional convergence, ratio test, and root test. So let's dive right in with a fairly straightforward problem. N over 5 to the n, that's our series. So the way this series is, the question is phrased is, we're just testing, all the question says is test the series for convergence or divergence. Okay, so the question doesn't explicitly ask for absolute convergence, conditional convergence, etc. It just asks for convergence or divergence. But what do we know? We know a series is convergent if it's absolutely convergent. So what we can do is we can test for absolute convergence, okay? And if the series is absolutely convergent, then it should be, that implies it's convergent, okay? And if our, so how do we test for absolute convergence? We have two nice tests, the ratio test and the root test, okay? So if these tests tell us that our series is absolutely convergent, then that will imply our series is convergent, okay? So the short story is we can use ratio test and root test just to tell if our series is convergent or not as well. Okay, so let's go to a new slide and look at this problem. Okay, so ratio test is going to be more common than root test. So I would, if you have a feeling you want to test for absolute convergence, I would start with ratio test unless there's some reason to think we should use root test. Okay, so looking at this problem, let's try and show it's absolutely convergent by using ratio test. So what do I need? I need to find an plus 1 over an, absolute value. Okay, so in that case, let's see, an plus 1 is going to be n plus 1 over 5 to the power of n plus 1. And then I'm going to be dividing by an, which is the same as multiplying by the reciprocal. So I'll have this. And I can simplify this. I'm going to get all my similar pieces together in one fraction. So I'm going to write n plus 1 over n, and then times 5n over 5n plus 1. And now let's simplify. The only thing I can simplify is this fraction here, and that simplifies as 1 over 5, right? All right, so this is my an plus 1 over an, and I want to find limit of an plus 1 over an. Okay, so the limit of this, what is the limit of this? Well, I can bring the 1/5 outside my limit. And then what do I have? I have this. So what's the limit of n plus 1 over n? If you want more simplification, we could say that's limit of 1 plus 1 over n, right? Okay, and we're talking about the limit as n goes to infinity. Maybe now it's clear that the limit, this limit is equal to 1. So 1/5 times that limit is equal to 1/5. Okay, so what do I have? I have the limit of an plus 1 over an is equal to 1/5. What does ratio test tell me? Well, 1/5 is less than 1. So my series, my original series, is absolutely convergent. Okay, so that's absolutely convergent, which implies it's convergent. So my series, I tested it using the ratio test, is absolutely convergent, which means it's convergent. All right, let's look at another series. All right, let's look at this problem. Okay, we have a factorial, and if you guys watch my lecture video, maybe you know when we see factorial, we should think ratio test first. So let's try ratio test again on this. And again, the instructions are the same. We're just testing whether it's convergent or divergent, but we're going to do it by ratio test, which will tell us whether something's absolutely convergent or divergent. And then we're going to use the fact that it's absolutely convergent to conclude it's convergent. Okay, so let's try and test whether this is absolutely convergent using ratio test. So again, I want an plus 1 over an. Okay, let's see what that is. An plus 1, let's see, I'm doing absolute values, so I can ignore all the negative signs. So that would be 3n plus 1 over 2. Now this is where it gets a little bit tricky. When I have an plus 1, this n in my factorial changes to n plus 1. Okay, I got to be careful how I apply that. Okay, so this is just an plus 1 here. Okay. And then I'm dividing by an, which would be the stuff in the original series, my original term, minus any negatives. Okay. So an plus 1 over an is equal to this. Now we start simplifying. Okay. So again, I'm going to get similar stuff in fractions together. Okay, this is just rearrangement, right? I haven't changed anything. Okay, now let's distribute this stuff out in this factorial. Okay, that might make it a little easier to see. This is going to end up being 2n plus 2 plus 1 factorial, right? Okay, so let's simplify this. 3n plus 1 over 3n, that's just 3, right? And then 2n plus 1 factorial, let's leave that like it is. And then 2n plus 2 plus 1, that's 2n plus 3 factorial. Now, if you guys are unclear what to do next, maybe look at my video about simplifying factorials. Okay, let's go to a new page. Okay. What is 2n plus 1 over 2n plus 3 factorial? Remember that's 2n plus 1 times 2n times dot, 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 all the way down to 1. And 2n plus 3 factorial, that would be 2n plus 3 times 2n plus 2 times 2n plus 1, dot, 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 all the way down to 1. So let's see, this would cancel with this, and that with the next term, and so on, all the way down to 1. And I'd be left with 3 times 1 over 2n plus 3 times 2n plus 2. Okay. Now, I have found this is my an plus 1 over an. Okay, so that's what this is. And now what do I need? I need to find the limit of an plus 1 over an. Okay, so what is the limit of this thing? Well, I can bring the 3 outside the limit, right? And say it's equal to this limit. And if you wanted to, you could multiply this out and see it was 4n squared plus blah, blah, blah. But that's not really necessary, right? As long as we know we have a 1 on top and 4n squared on the bottom, plus some other stuff, what's the limit going to be? Okay, limit of 1 over 4n squared, that's 0. So this limit is equal to 3 times 0, which is 0. Okay. Now, what does ratio test tell me? Okay, I have limit an plus 1 over an is equal to 0. So ratio test tells me, since this is less than 1, my series is absolutely convergent, which implies my series is convergent. So my series, which I started with, which is this, is convergent. All right, this looks like an interesting one. Let's try this series. So n factorial over n to the power n, and again, we're just testing for convergence or divergence. So factorial, okay, makes me think ratio test. We'll move on to root test in a minute, but let's do this via ratio test again. So once again, I want an plus 1 over an, okay? So let's see, what's that? That would be n plus 1 factorial over n plus 1 to the power of n plus 1. And then let's see, I'm dividing by an, which means multiplying by the reciprocal, which would be n to the n over n factorial. Okay. Everything's positive, so I can drop the absolute value bars. And again, I want to get similar stuff in fractions together. The question is, how can we simplify this? Because we got to take the limit, right? All right, let's see. I'll drop the absolute value bars now. N plus 1 over n plus 1 factorial over n factorial. That's going to simplify to n plus 1. And again, if you're having trouble with that, see that simplifying factorials video. N factorial over n to the power n over n plus 1 to the power of n plus 1. How can we work with that? Well, first of all, n plus 1 to the power of n plus 1, we can consider that as n plus 1 to the power n times n plus 1, right? And now these n plus 1s we can cancel. Okay. So I have n to the power n over n plus 1 to the power n, which is equal to n over n plus 1 to the power n. Now the question is, what's this limit? This one's a bit tricky. What if I had it flipped upside down? What if instead of n over n plus 1, I had n plus 1 over n to the power n, which I could rewrite as 1 plus 1 over n to the power n. Does this limit look familiar? You might remember it from earlier in the semester. I said this is an important limit. This is equal to the number e. Okay. So since this is, let's see, this n plus 1 over n is what we have flipped over. Okay, we could say that this limit should be e to the negative 1. Okay. In other words, it's 1 over e. So this one's a little weird, but it works out. Limit of an plus 1 over an is going to end up being 1 over e. Now, the question is this limit less than 1, greater than 1, or equal to 1? Well, remember, e itself is 2 point something, so 1 over e is going to be less than 1. Okay, so our limit is less than 1, so our series is absolutely convergent, which implies convergent. Okay, let's do one more ratio test problem. How about alternating series, negative 1 to the n, 2/3 to the power n, and factorial. So again, an plus 1 over an, absolute value. Absolute value allows me to drop the negative sign or the negative terms. So I can write an plus 1 as just, let's see, 2/3 n plus 1, n plus 1 factorial, let's see, over 2/3 to n factorial. Okay, now let's simplify. Okay, so I have 2/3 to the n plus 1 over 2/3 to the n. That's equal to just 2/3. Then n plus 1 factorial over n factorial. That simplifies as n plus 1. Okay, so what is the limit as n approaches infinity? An plus 1 over an. It's going to be equal to 2/3 limit of n plus 1. Okay, what is this limit? What is the limit of n plus 1 as n goes to infinity? That's equal to infinity. 2/3 times infinity is still infinity. So we have our limit is equal to infinity. Okay, so what does our ratio test tell us? If our limit is greater than 1 or infinity, our series is divergent. Okay, so our original series is divergent. Okay, so now we've seen the two cases now of there's three cases for ratio test, right? If the limit's less than 1, it's convergent. If it's greater than 1, it's divergent, which we've just seen here. And then if the limit is equal to 1, it's inconclusive. But we haven't seen that case yet. We'll see that later on. Okay, for now, let's try some root test problems. Let's try this one. So what's cluing me in that I should use root test is that everything is to the power n. Okay, so when I do root test, meaning I take the nth root of absolute value of an, okay, that the nth root and the power of n should cancel out nicely. Okay, so now let's figure out what this is, the nth root of an. Okay, so I want to take the nth root of an. What's my an? The an is just the stuff inside my series. Okay. So what happens when I take the nth root of something to the power n? Those n, the nth root and the n cancel, and I'm left with n squared plus 1 over 2n squared plus 1. And then I want to take the limit of this. Okay. So that's going to be equal to the limit as n approaches infinity of n squared plus 1 over 2n squared plus 1. What is this limit? Okay, we have the same power of n on top and bottom. So I look at the coefficients. The limit should be equal to 1/2. Since 1/2 is less than 1, root test says my series is absolutely convergent, which means it is convergent. Now let's see this one. I think this is a good example here. So now I'm considering this series, -2 to the n over n plus 1 to the power of 5n. Okay, so again, I try and find nth root of absolute value of an. Okay, so absolute value, I can ignore that negative sign. And I take nth root of this. This is this term here. When I drop the negative, this is equal to the absolute value of an. Okay, so let's see. I have an n here and a 5n here. So how does that cancel? Does this entire term cancel? No. Remember, nth root That's like doing this. Okay, this is my an inside, and then I'm raising it to the power of 1 over n. And when I have something to an exponent and I raise it to another exponent, what do I do with the exponents? I multiply them together. So what I have is 2n over n plus 1, and I multiply 5n and 1 over n. So what is 5n times 1 over n? I have the power 5. Okay. So what is now, next step is I need to find this limit, right? I have 2n over n plus 1 to the power 5. Well, what's the limit of the stuff inside the limit? Okay, I have same power of n on top and bottom. So the limit of the stuff inside the parentheses. I have same power on top and bottom. So the limit of this stuff is 2, and then I have 2 to the 5th. So the limit should be 2 to the 5th, which is what? 32. So my limit's 32, which is definitely greater than 1. So what does root test tell me? It tells me my series is divergent. All right, now let's transition to the next phase of our problems. Now let's look at problems where we want to show something is absolutely convergent, conditionally convergent, or divergent. So the instructions for the rest of the video will be, we'll be given a series and we want to show it's one of these three things. Okay. So ratio test and root test, if you remember what they say, they can show us two things. They can either show if the limit's less than 1, our series is absolutely convergent, or if the limit's greater than 1, it can be divergent. Ratio test and root test can never show us this. Okay, so we need some other mechanism to show this. Usually, our series is going to be conditionally convergent when our limit is equal to 1, that inconclusive case. But we'll go over that more when we get to one of those problems. Okay. So let's look at this problem. Okay, similar to some problems we were just working on, I got 1 minus n over 2 plus 3n all to the power n. Since everything's to the power n, that makes me think root test. So let's first find out what this looks like, nth root of absolute value of an. Okay, so this is a little weird because if you look at what's going on with these terms, we got 1 minus n. So let's see, for n equal to 2, I would have negative 1 over 2 plus 3n. And then for, let's see, n equals 3, I'd have negative 2. And so stuff in here would always be negative. And then depending on my power outside, it'd either be a positive or a negative. Okay. So how can I write this as an absolute value? Let's see. I could note that 1 minus n plus 3n to the n times negative 1. Okay. To the n equals n minus 1 over 2 plus 3n all to the power n. Okay. You can try this on your own. Basically, what I've just done is I brought this negative sign inside, and I got this. So it just switches the order of subtraction. And now everything in here is always positive. So what I'm trying to say is that if I consider the absolute value of this, it just becomes absolute value of an is equal to n minus 1 over 2 plus 3n. Okay. So nth root of an is equal to the nth root of n minus 1 over 2 plus 3n all to the power n. Nth root and n cancel. And I get this. Now, what is the limit of the nth root of an? That's equal to, let's see, power of n is same on top and bottom, so I look at the coefficients. Limit is equal to 1 over 3. That is less than 1. So by root test, my series is absolutely convergent. Okay. So this one's absolutely convergent. How about this series? Okay. Now my default would be to try and do ratio tests. So trying ratio tests, I need to find out what an plus 1 over an is. Let's see, since it's absolute values, I can ignore this negative sign here. Let's see, an plus 1 would be 9 to the n plus 1 over n plus 1 times 10 to the n plus 2, right? Because I already have n plus 1 here. I replace n with n plus 1, and I get n plus 2. Okay. Now I divide by an, which means multiplying by the reciprocal. Okay. Now I want to simplify, so I'm going to get the similar stuff together in fractions. So I have 9n plus 1 over 9n. Then I have 10. Let's do the n and the n plus 1 separately. So I got n over n plus 1 times 10 to the n plus 1 over 10 to the n plus 2. Okay, so now I got 3 parts, right? So let's simplify those. 9n plus 1 over 9n, that is equal to 9. Then I got n over n plus 1. And then 10n plus 1 over 10n plus 2 equals 1 over 10. So let's put this 9 and 1 over 10 over into 9 over 10. And then I got n over n plus 1. Okay, so this is my an plus 1 over an. What is the limit of this thing? Well, I can bring the 9 over 10 outside the limit. And then I got limit of n over n plus 1. This limit is equal to 1, so the whole thing is equal to 9 over 10. So my limit is equal to 9 over 10, which is less than 1. So again, by ratio test, I have absolutely convergent, meaning my original series is absolutely convergent. All right, here's a good one. Start at n equals 2. Okay, so I have everything to the power n. That makes me think root test. So I need to find, okay, nth root of absolute value of an. I don't have any negatives here, so that's not going to be a problem. I want to take nth root of, this is my an. Let's see. Okay, so I got n and a power n. Those cancel. Excuse me, I got an nth root and a power n. So those cancel. And I have this is equal to n over ln of n. Okay, now what is the limit of that? What is limit? Okay. I have this limit is going to be equal to the limit of this thing. So which grows faster, n or ln of n? Think about that hierarchy of functions. I know that n grows a lot faster than this thing in the denominator, so my limit should be equal to infinity. And if we wanted to do something more concrete, you could turn these into functions of x and do L'Hopital's rule, and you would see that this limit is equal to infinity. Okay, so limit is equal to infinity. So what does root test tell me? Okay, since the limit's equal to infinity, my original series is going to be divergent. Okay, so far so good. Now let's try this one. This is an interesting one. And this might answer your question on conditionally convergent as well. Okay, so we're looking at this series starting at n equals 2 and going to infinity, -1 to the n over ln of n. Okay, so maybe my default mode is to try ratio test. So let's try ratio test and see what we get. Okay, so let's figure out what an plus 1 over an is, absolute value. Okay, since I'm talking about absolute values, I can ignore the negatives, and I would have this thing, an plus 1 over an equals ln of n over ln of n plus 1. So what's the limit of that? Okay. Now, it's kind of hard to tell, right? So if I turn these into functions of x, if I said, okay, instead of thinking about n's, I was thinking about this. Okay, now these are differentiable functions, and I can use L'Hopital's. So the limit of this thing would be, let's say, derivative of top over derivative of bottom. So that would end up being the limit of x plus 1 over x equals 1. Okay, so that means the limit of this thing is 1. So what does my ratio test tell me? That's that inconclusive case, right? So I don't know what's going on. This is a good clue. Whenever we get limit is equal to 1, it's usually going to be because our series is not absolutely convergent and not divergent. Okay, so it's neither of these things. It's going to be that third possibility, conditionally convergent. Okay, so now how do I show this? Let's go to a new slide now. How do I show, remember the definition of conditionally convergent. Conditionally convergent is when we have, okay, when we're looking at series AN, it's going to be conditionally convergent if two things happen. The series of absolute values is divergent and the original series convergent. Okay, so looking at, I need to show these two things. I need to show that series of absolute values, 1 over ln of n. I need to show this is divergent, and I need to show that this thing, my original, is convergent. Okay. Let's do this, well, let's do number 2 first. Number 2 is easier. How can I show that my original is convergent? So forget about ratio test, root test. This is an alternating series, right? So could I use alternating series test? Yeah. Okay, what do I got? I got terms are decreasing and the limit of this part is 0. So by alternating series test, this thing is convergent. Okay, so convergent by alternating series test. Cool. How can I show that this 1 over ln of n is divergent? That's a bit trickier, but we could do comparison test, right? Ln of n is less than or equal to n. So 1 over ln of n is greater than or equal to 1 over n. So my series here of absolute values should be greater than or equal to the harmonic series. This is divergent. So my comparison test tells me this is divergent. Okay. So we could say this is divergent by comparison test. Okay. So I've showed my two things. I've shown absolute values are divergent and my original is convergent. That is the very definition of conditional convergence. So to wrap it up, you could say, since absolute values divergent and original convergent, series is conditionally convergent. Okay. So that's how we show something's conditionally convergent. We always, whenever we're doing conditionally convergent, we have to do these two things. We got to show the series of absolute values is divergent, and then we got to show the original is convergent. Usually, this is going to be showing convergent is going to be by alternating series test, usually in our case. And then this will be something, maybe comparison, integral test, p-test, something like that. One of our other series. Whenever we're showing conditional convergence, we can't use ratio test and root test to get to our conclusion. So going back to the previous slide, when we did ratio test, we saw the limits equal to 1, so that's inconclusive. That's just showing that ratio test and root test are never going to give us a clear answer when something's conditionally convergent. So whenever we're trying to show conditional convergence, we got to rely on our other methods. All right, I think that's a good place to wrap up for this problem session. Let me know if you guys have any questions.